Hey everybody, this is the video for problems 11 through 14. Okay, these are all the equations. Okay, for number 11, that's the most straightforward situation. The thing that's nice about number 11 is we got exponentials, we got x's on both sides. Yeah, and the bases are the same. The bases are just both 2. It's 2 to some power equals 2 to some power. When you have that type of an exponential equation, all you have to do is forget about the 2's, set the exponents equal to each other. Okay? That's the best case scenario when you walk to an exponential equation. Base to a power equals the same base to a different power, set the exponents equal to each other. Now we've got to solve this equation. I'm going to move the x's over to one side. And the numbers on the other side, divide both sides by -1. If negative x equals -7, x equals 7. That's my answer. Okay. 12 is a little trickier. I have exponentials on both sides. I have x's on both sides. So I want the bases to be the same and kind of do it like I did number 11. But the problem is the bases are different. One's 6, the other one's 36. Now, the nice thing is, those aren't like random numbers. It's not like 12 and 91 or 3 and 17. Those numbers have something to do with each other. There's a connection between the bases. What's the connection? Well, if I'm thinking about exponents, the connection is, well, 36, that's 6 squared. So I'm going to rewrite that 36 as 6 squared. I'm going to leave the left side the same. And then remember, I still have this 2x minus 4. It's really important that you put that in parentheses. So now what I've done is made this into one that looks just like number 11. I got 6 to some power equals 6 to some power. So now I'm just going to set the exponents equal to each other. So I'm going to set x plus 11 equal to 2 times 2x minus 4, and I'm going to solve this equation. Distribute. Regular old linear equation. You guys know how to do this. X is on one side, so I'm going to move the x's over to the right side. I'm going to move the numbers over to the left side, so I'm going to move that 8 over there. And I'm left with 19 equals 3x. Last step, divide both sides by 3. And I'm done. X equals 19 divided by 3. If you want to type that in your calculator and get a decimal, you can, but you definitely don't have to. Okay? Number 13 is different. How is it different? Well, there's only one exponential part. There's not x's on both sides. There's not exponential parts on both sides. There's just one exponential part. Okay? This is the one where I'm going to have to rewrite it in log form. Before I do that, though, I need to get the exponential part by itself. I need it to look like this. Number equals b to some power. I need it to look like that before I can rewrite it in log form. So I need to get this 7 to the x by itself. How do I do that? I add the 1 over. Yeah, I got it looking how I want it to look. I got the exponential part by itself. Now I'm ready to rewrite it in log form. Okay, so use your little puzzle. Definitely have that on your note card. Rewrite it in log form. It should be log base 7 of 13 equals x. Calculator time. Remember that this is a number. Grab the calculator, type that in. Hopefully you've been doing that for the last couple of weeks and you know how to type that in a calculator. If not, that's definitely something that you need to ask your teacher about. Type in your calculator, get our number. I got 1.318, and the x is already by itself, so I don't need to do any extra solving. I am done. Okay. Number 13 is a little trickier, but very similar. There's only one exponential part, so I'm not going to get, I don't have exponentials or x's on both sides. So instead, I'm going to do what I did in 13. I'm going to have to use logs. My first goal is to get this exponential part by itself. Add 1. Careful here, the exponential part still isn't by itself. This is the exponential part. I still got that annoying 2 hanging out front. I got to get rid of it. How do I get rid of that 2? Divide both sides by 2. Now the exponential part's by itself. The mistake that kids make is they're like, oh, I gotta use logs, I gotta flip it in the log form, and they like try and flip it in the log form real quick. Take your time, get the exponential part by itself before you flip it into log. Only when it looks like number power equals number can you rewrite it in log form. Now I'm ready to rewrite it in log form. Okay, I'm going to use my little puzzle thing. What's the base of the... Okay, the e goes there, the 5x goes there, and the 7 goes there. Cool. This is a number. I can type this in my calculator. The easiest way to type this in your calculator is be like, oh wait, yeah, log base e? Log base e, oh yeah, there's that different thing for it. Natural log, ln. Okay, so change that log base e to an ln. Then when you go and type in your calculator, you don't have to even use the log button, you can use that ln button. If you have a TI graphing calculator, that ln button is right next to the 4 key. Okay, so right to the left of the 4 keys, that ln, just type ln 7. You should get out 1.946, I'm going to round the 5 up, equals 5x. And now I got to do a tiny bit more solving. What do I still have to do? I'll just divide both sides by 5. Oops. I got 0.389. And I'm done. Okay. That concludes this video. Thanks for watching, guys.